Okay, so let's look at some examples of NPV and IRR technique. Um, First one is, given the following cash flows for a capital project, calculate the NPV and IRR. The required rate of return here is 8%. So we are provided with some cash flows, cash outflows, and then cash inflows. For these cash flows, we want to find out what is the required rate. The required rate of return is given to us 8%. We want to find out the NPV and IRR for this capital project. So let's do this on Excel. What are the cash flows? Minus 50,000, 15,000, 15,000, 20, 10 and 5. Okay, so these are the cash flows and we want to find out the NPV and IRR. So let's do this. Discount rate given to us is, required rate of return is 8%. Present value of cash flows can be calculated as cash flow divided by the discount rate raised to the power duration period. This can also be calculated through discount value factors. And we can multiply the discount value factors with cash flows. So the NPV of the project is 3,378.8, and let's calculate the IRR also. IRR is the discount rate at which the NPV becomes 0, and IRR can be calculated on Excel using the IRR function of Excel, where we provide all the cash flows. So IRR is 11%. To be very precise, it is 10.88%. So this is the discount rate at which the NPV will become 0, or this can also be called as the internal rate of return or the actual rate of return provided by the project if these cash flows turn out to be true. Let's look at next example where it is also related to both NPV and IRR, and we are reviewing a profitable investment project that has a conventional cash flow pattern. By conventional cash flow pattern, we mean those cash flows which are changing sign just once. If the cash flows for the project initial outlay and future after tax cash flows all double, the IRR would. So we are not provided with any values here. The question is, if the cash flows for the project initial outlay and future after tax cash flows all double, what would be the impact on IRR and NPV? So that means let's take an example here. if the cash flows for the project, initial outlay and future after tax cash flows all double. So let's assume some values, and then we will be able to uh, double those values and see what is happening. So okay, so let's assume these cash flows. Initial outlay is $1,000 and the inflows is $400 for 5 years. And let's figure out what would be the IRR for this project. So IRR of this project is 28.65, and let's figure out the NPV. We'll just assume some discount rate. Let's assume it to be 10% and figure out what is the NPV of these cash flows. So NPV is 516.3. Let's note it down. And IRR is 28.65. Okay. So this is what we are getting with these cash flows. NPV of 516.3 and IRR of 28.65%. Now what we'll do, as the questions ask for, if everything doubles, the cash flows double, then what will be the impact on NPV and IRR? So let's make it minus 2000 here and make these cash flows as 800. Now what is the impact? We see NPV has doubled, but IRR remains the same. Yeah. So if all the cash flows, initial outlay and after tax cash flows double, if all these cash flows double, the NPV doubles, but the IRR remains the same. Let's look at one more question. Here we are given with two projects which have similar outlays. We can see from the table it is minus 50 for both. Although pattern of future cash flows are different, the cash flows as well as the NPV and IRR are shown below. For both the projects, the required rate of return is 10%. Comment on how the company should decide to invest. So here we need to figure out in which project should the company invest, or it can be both. So if we look at the decision making criteria for NPV, it says that if NPV is positive, we should go ahead with the project. In this case, NPV for both the projects is positive. For project 1, it is 13.40, and for project 2, it is 18.30. So that means both the projects have a positive NPV. So as per the NPV decision making criteria, both are good to go ahead. Now let's look at IRR. The required rate of return is 10%, and both the projects are also generating a return of more than 10%. So as per the IRR decision making criteria as well. If IRR is greater than the required rate of return, we should go ahead with the projects. So in this case, what we can say is that if the company has the capital to invest in both the projects, they can take up both the projects. But in case they want to take up one only, then we can suggest that they should go for project 2 because that has a higher NPV. That means the increase in the value of the firm would be 18.30 as compared to project 1, which is only giving a NPV of 13.4. So by investing 50, we are getting more value from project 2. Net present value is higher, 18.30, and the objective with which we work is maximizing the value of the firm, the shareholders' wealth. So from that perspective, project 2 will increase the value of the firm by 18.3%, 18.3 versus project 1, which is only increasing the value of the firm by 13.4%, 13.40. So from that perspective, from the amount of NPV generated perspective, project 2 is better than project 1. Okay, let's look at one more question. How many discount rates produce a 0 NPV for this project? Okay, so let's look at the cash flows for this project. -50, 100, 0 and -50. So it is a non-conventional cash flow pattern where the sign is getting changed more than once. In this case, we have seen that there can be multiple discount rates which give you an NPV of 0. So let's figure out. Options are one discount rate, which is 0%, two discount rates, 0 and 32%, two discount rates, 0 and 62%. So basically 0%, 32% and 62%. Which of these discount rates give a NPV of 0? So let's do it. Cash flows are -50 plus 100, 0, -50. Now, which discount rate will give us an NPV of 0? If the discount rate is 32%, let's try with 32%. What is the NPV we are getting? So NPV is coming out to be 4. So discount rate of 32% is not giving us a NPV of 0. Okay, so let's look at discount rate of 0. Yes, discount rate of 0 is giving a NPV of 0. And let's try with 62%. Discount rate 62% is also giving a NPV of 0. So that means there are two discount rates, 0% and 62%, which are giving us a NPV of 0. So now let's look at one more concept, which is modified IRR. We saw that IRR has two limitations. One significant drawback is that IRR assumes that cash flows are reinvested at the calculated IRR, which may not be a practical assumption. So the problem with IRR was that it assumes that all the interim cash flows will be reinvested at the same rate of IRR, which may not be practical. And this limitation is overcome by modified IRR, MIRR, which is a financial metric used to evaluate an investment or project by considering both the reinvestment and financing of cash flows. It is used to address the limitations of IRR, especially the reinvestment assumption. MIRR provides a more realistic perspective by assuming reinvestment at a rate different from the project's IRR. So what we said was that assumption of IRR that all the interim cash flows will be reinvested at IRR is not realistic, is not practical. That may not be practically possible. So that limitation is overcome by this modified IRR, where it allows us to punch in a different reinvestment rate. So now our discount rate can be different from the reinvestment rate at which we will be able to reinvest our interim cash flows. Advantages of MIRR. MIRR overcomes the problems associated with IRR by using a more realistic reinvestment rate assumption. It considers both the cost of financing reinvestment and the cost of obtaining funds financing at different rates. MIRR often provides a more accurate reflection of the project's profitability. While IRR and MIRR serve similar purposes, MIRR is preferred when there is a significant difference between the project's IRR and the rate at which cash flows can be reinvested or financed. So what is the main difference between IRR and modified IRR is that if we think that interim cash flows cannot be reinvested at the same rate as IRR, then IRR is not giving us a realistic picture. We can get a more realistic picture by looking at MIRR in that case and assuming a different reinvestment rate than the IRR of the project. Then the returns we get by assuming a different reinvestment rate, then the returns we get will be captured by MIRR, not IRR. So how do we calculate it? We use the function of MIRR on Excel, and we give all the cash flows first. Then we give the finance rate, that is our cost of capital, or that is the discount rate, comma, the reinvestment rate, which we expect to our interim cash flows to be reinvested at this rate of 8%, that is MIRR. So let's look at how it works. So let's assume these are the cash flows we are looking at. Minus 1,000 is the present cash flow, cash outflow, and then these are the cash flows we are looking at for next 5 periods. Then what is the IRR? We can calculate it through IRR function. IRR comes out to be 19%. Now when we say IRR is 19%, it is based on the assumption that all the interim cash flows will be reinvested at 19%. So this 200 will be reinvested at 19% for 4 years. This 250 will be reinvested at 19% for next 3 years, and so on. If that does not happen, if this does not seem practical, then we should not look at IRR, we should look at MIRR. In that case, what we'll do, we'll assume a discount rate and we will put in a more realistic reinvestment rate. In that case, we can calculate MIRR as 17%. So it is lower than IRR. Why? Because we are reinvesting our interim cash flows not at 19%, but at 15% only. So that is why the overall return we are getting from the project is 17%, assuming that we will reinvest at 15%. So this is the usefulness of MIRR. So to compare it with IRR, IRR is suitable when reinvestment rates are expected to be consistent with the project's IRR. So that means when we expect the reinvestment rates to be same as the project's IRR, when we can achieve that, IRR is a suitable measure of profitability. Whereas MIRR is preferred when reinvestment and financing rates are significantly different from the IRR. So when we know that we will not be able to reinvest at the same rate as project's IRR, when our reinvestment and financing rates would be different, in that case, MIRR is preferred over IRR. So these are varying on the basis of 3 aspects. One is reinvestment assumption. IRR assumes reinvestment at IRR, whereas MIRR allows different rates for reinvestment assumption. Multiple IRRs may result in multiple values, provides a unique value. And financing consideration, IRR ignores financing cost. We don't look at cost of capital, or we don't look at the discount rate when we are doing the IRR calculation, whereas MIRR considers financing cost.